Okay, so what we're going to be talking about today is exponential models, word problems with exponents and exponential equations. What we're going to do 2 lessons of this, then we will review on Monday, and you have a quiz on Wednesday. Okay, so the 2 lessons are today and Friday for you guys. So 2 new lessons, review on Monday, quiz on Wednesday. Okay, so very important that you hear and you keep up with the homework in this lesson. And then we'll do 2 more lessons, review and quiz, and finish up exponents. So we're breaking this into 2 sections with 2 different quizzes, just to keep the amount of material shorter on each one. Now, you're going to need to get used to working with your calculator, entering expressions that look like this. We've been working with the number e, which is what? The natural what? E is the natural exponent, and then log base e is natural logarithm, okay? So just to let you know where that number comes from, this is where the number e comes from. If you look at 1 plus 1 over n to the n, this is not something you're tested on, but I just want to show you this. So if I did n equal 10, so if I did 1 plus 1/10 to the 10th power, and what I want you to do is get used to doing things like that on your calculator. So 1 plus 1/10 to the 10th power. So 1 plus 1/10, and then all of that raised to the 10th power is 2.594. Okay, so 2.594. Okay, let's do the same thing with a larger number of n, like 1,000. So 1 plus 1 over 1,000 raised to the 1,000th power. Let's see what that is. So 1, and the good thing about your calculator is it allows you to enter just like it would be on the paper. 1 over 1,000, and then raise that to the 1,000th power, and that is 2.717. And then let's go for a larger number, 100,000. So 1 plus 1 over 100,000, all of that raised to the 100,000th power. And this is where you should be thankful you've got a calculator to do this. So 1 plus 1 divided by 100,000, all of that raised to the 100,000th power, 2.7183. And on your calculator, we've seen this number e is 2.1783, so we get closer and closer to that number. So this number e that we've been working with and we will continue to work with is not a number that just came out of thin air. It's the limit as n gets to be a very large number of 1 plus 1 over n to the n, okay? That's just where this number comes from. So it's just a number like pi. It's irrational. It never repeats, never terminates. Now, what we're going to be dealing with in this section are exponential models. These are applications where there's an equation underlying it that has an exponential. And they're going to look something like this. Y equal ab to the x, or a times parentheses b to the x, okay? Now, in all of these, what we're solving for on the left, y, is going to represent a future value. So if I'm talking about a population that is growing, what's the future value? Yeah, future population, the number of people 10 years from now. If I'm talking about money you put in a bank account, what's the future value? Hopefully it's the amount of money after you earned interest or the investment made money, okay? In this case, this number A is always going to represent my initial value. So if I were talking about population of College Park, the initial value would be what the population is when? Right now. Future value is what it is sometime in the future, okay? If I were talking about a bank account, initial value is what? What you put in now and then hope to earn interest later, okay? B is going to represent something called a growth or decay factor. If something is doubling every year, is that growing or decaying? If something doubles every year, growing. If something is cut in half every year, what is that doing? That's decaying, okay? So if this B, if it's a number greater than 1, I've got exponential growth. You know, if it's a number between 0 and 1, it's a fraction, then I've got exponential decay, okay, or decline. X, this exponent here, will always, in all of our models, represent time, okay? So I'm talking about a bank account. You deposited money for 10 years, or population in 10 years, okay? Or some radioactive substance, how long until it decays, okay? You know, the effects of a drug in your bloodstream over time. Our exponent will always be time in these equations. Now you remember from last semester, that red graph, that's the graph of 2 to the x. The blue one here, this is 1/2 to the x. Which of these models is exponential growth? The red one. So if you look at it, as I go from left to right, my numbers are increasing. I am growing. If you look at the blue one, as I go from left to right, instead of growing, I'm doing what? I'm declining. I'm decaying. Okay? So that's the difference between exponential growth and exponential decay. Now, let's just take a look at a few examples. In this section, in every case, I'm going to give you the model and tell you what every variable is, and then ask you questions about it. The predicted population of a city is modeled by the equation P of t equal 56,000 e to the 0.45 t. That's an exponential model because it has an exponential equation. How many people live in this city today? How many people live in this city that I'm talking about? Yeah, I'm on math today, Annie. Okay. How many people live in this city today? 56,000. Okay. Why 56,000? That's the initial value. Okay. So it tells me that t represents what? What does that say? T years from now. How many years from now is now? 0. Okay. So to find the initial population, that's going to be 56,000 e to the 0.45 times 0. What's e to the 0? E to the 0 is 1. So this is 56,000, okay? So that is the initial population. And you don't have to go through that calculation. What we just said a moment ago, when we looked at this, when you have something that looks like this, y equal ab to the x, whatever this number a is, that is your what? Initial value. So if I look at this equation, I shouldn't have to do a lot of work to know 56,000 is my initial value, okay? So the population today in this city is 56,000, and t is equal to what? 0. So 0 years from now, the population is 56,000. Now, how many people will live in this city in the year 2030? Right, so how many years from now is 2030? So 2030, what is the current year? Yeah, minus 2019 is 11. So 11 years from now, how many people live in this city? All you have to do is plug in 11 into which variable? T. So it's 56,000 e to the 0.45 times 11. And anybody know that off the top of it? It was written there, but you just use your TI Inspire. 56,000 times. And the way you get to E is you take the pi key here, and then you select E, and you raise that to the, what was it, 0.45 times 11. So the nice thing is you don't have to do you don't have to say 0.45 times 11 and then e to that power. You don't have to write multiple steps. I can put the whole equation here, 56,000 e to the 0.45 times 11, and that is 790, 5798. So 790, 5798. Now, this is a word problem. Your answer cannot just have a number. It needs to have what? It's a word problem. Your answer has words. What does this number represent? Population. So this is the population in what? Yeah, in 2030. You could say it's the population in 2030 or the population 11 years from now. Either way. Okay, so you don't have to write War and Peace there. Just give me a number, give me a unit, and tell me, okay, what was a good way of looking at it? What's the question? The question is, what's the population in 2030? 9 blah 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 is the population in 2030. Does the answer complete your question? Okay, that's all I'm really looking for here. So all we did was substitute the value of 11 because 11 is what represents 2030 in this case. Okay, pretty straightforward. Okay, let's mix it up a little bit and let's look at this particular question. Now, in what year would the population triple? Okay, when I read something like in what year, from 56,000, so from the initial, okay? In what year would the population triple, okay? So, in what year, what kind of variable is that? Time, space, monkeys, people, dollars, what is it? What is it? I'm talking about, no, in what year, what variable? That's talking about what? Years, which is what? Time. Time is always my what in these models? It's t, but it's little and it's raised up. We call that a what? Exponent. Time is always my exponent. Danny thought it was like a game show over there. You know, he's just like, you know. Yeah. So time is my exponent. How do I solve for an exponent? Pretend like you had a quiz this week and you had to solve for an exponent. What would you do to solve for an exponent? What would you do? Pardon me? You would get it by itself and then you would do what? What was our quiz over? Quiz was over logarithms. Can you use logarithms to solve for an exponent? Answer would be yes. You take the logarithm of both sides. That's going to be our process. So let's just take this out. What will when will the population triple? First of all, what will the population be when it triples? Yeah, it's 3 times 56,000, which is what? 168,000. So they're asking me, when will the population hit 168,000? So that is my initial value, future value. What is that? Future value. So the equation I'm looking at is 168,000. My future value is equal to my initial value and then e to the 0.45 t. And what am I solving for here? T, okay? If I can solve for t, I need to get this all by itself. What's keeping it from being by itself? No. What's in that red box needs to be all by itself. It's not by itself. What is it with? It's what? No. I understand. What's in the red box, I want that to be the only thing on the right side. It's not the only thing on the right side. How can I make it the only thing on the right side of the equation? Divide by what? 56,000. Okay. What is, and now this one should be pretty straightforward, what's 168,000 divided by 56,000? It's 3. We've already figured that out. So 3 is equal to, what's over here on the right? Yeah. 3 is equal to e to the 0.45t. Now I have an exponential on one side of the equation. To solve for the exponent, I need to do what to both sides of this equation? Not divide, not add. I need to take the log. What base? Log base e, which is called natural log. So do you want me to write log base e or natural log? Why do you want me to write it? Okay, let's just write it log base e. So log base e of 3 equal the log base e of e to the 0.45 t. Now, why did I do that? What is the right side now? Log base e of e to the 0.45 t is what? 0.45 t, okay? These are inverse functions of each other. Log base e of e to, I don't care what this is, that's the answer. So, because they're inverse functions of each other. E to the 0.45t does something. Whatever it does, log base e undoes it. These are inverse functions. Well, I could move it around. It could be on the left. Why I have what? Well, I took the log of both sides of the equation. Log of the left equal log of the right. On the right side, log base e of e to the 0.45t. Yeah, I want to solve for the exponent. The exponent is which number, which variable? T. T is not by itself right now. What do I need to do to t to get it by itself right now? Divide by what? 0.45. So t is equal to the log base e of 3 over 0.45. Another way to writing log base e is just ln. So this is t is equal to ln of 3 over 0.45. Okay, this is algebraic solving for a variable, but there are logarithms in there. Anybody off the top of their head know what the natural log of 3 divided by 0.45 is? How would you figure that out? Yeah, so I need to know what is the natural log of 3 divided by 0.45. Okay, 2.441. So t is equal to 2.441. What was the original question? In what year would the population triple? So will it triple in the year 2.441? No. What does 2.441 mean? It means how many years from now? So if I look at 2019 and I add 2.441, what year is that? So 2021.441, what year is that? That's the year 2021. Okay, maybe it's around April, or something like that. It's partly through 2021. You don't round it up and say, oh, it's 2022. You understand that? So it's 2.4 years from now is in the year 2021. Okay, it's not January of that year. It may be April or May of that year, somewhere in that. So the answer to the question is the population will triple in what year? In 2021. If I had asked you how many years from now will the population triple, what is that answer? 2.441 years. So the population will triple in 2.441 years. That year happens to be the year 2021. Okay? So just pay attention to the way the problem is wording, especially with years. Okay? So if this had been like, if it had said 2021.9, do you round that up to the year 2022? If I said that it's going to triple in the year 2021.9, do I round that up? Yes or no? No, that just means later in the year of 2021. That means it's going to happen in December, but the year is 2021. Okay? So in all of these problems, I will give you a model. You need to interpret the units, and I'm either going to ask you to solve for a future value or an exponent. The exponent always represents the variable of what? What is that exponent? It's always what? Starts with a t. Time, okay? The variable always, the exponent always represents time. If I'm solving for the exponent, I need to know how to do what? Get it by itself and take what? On both sides. Guys, we did this on the quiz earlier this week. Logarithms of both sides. That's the way I solved for an exponent. It was the way you did it on the quiz. You solve for an exponent by taking the logarithm of both sides, okay? You're going to need to keep that skill handy, okay? Now let's look at this. A hybrid car has a battery. The battery needs replacing periodically to ensure proper operation. The power in the battery decreases according to this model. W of D, that is the wattage, is 40e to the negative 0.06 times D, where W is the amount of wattage and D is the number of days since the battery was put in use. Is this exponential growth or exponential decay? Decay. The power in the battery is not increasing. The power in the battery is decreasing as the battery gets older. How many watts are initially in this battery? 40. Okay, don't miss this question. I mean, it's just as hard as looking, what is that number? 40 what? 40 watts. That's how many power, that's how much power is initially in this battery. Okay, you can just look at the model and see that. Okay, how much power in watts is left in the battery after 48 hours? Okay, so they're giving me a time and I get to plug that in. Now, if you look at your original equation, D represents time. D is, what unit of measure is it? Days, okay? How many days is 48 hours? Anyone? 2 days, okay? So they're asking me, what is the wattage of this battery after 2 days? What will I do to figure this out? Plug the 2 in for which variable? D, okay? So I'm going to get 40 e to the minus 0.06 times 2. I'm just plugging in the value of 2 days into that equation. Off the top of your head, does anyone know this one? I'm guessing no. So it is what? 40 times e to the minus point, is it 06 times 2? Was that it? Minus 0.06 times 2. Okay, and that is 35.47. So 35.47. That number means what? What is that? It means what? It's the wattage. Okay, so it's 35.47 watts after what? Yeah, after 2 days. Okay. Pardon me? After watts, meaning? No. 35.47 watts after 2 days. So that's the power in this battery after 2 days. And we expect it to go down because this is decaying. The power in that battery is decaying over time. Now, the next thing they're asking is how many days does it take? Before I go any further, this question is about solving for what kind of variable? Time. Time is always my exponent. If I'm solving for an exponent, I have to take what? The log of both sides. Okay, so I'm solving for time here. So how many days does it take for the battery to get down to 15 watts? Okay, so the equation here is 15 equal what? What's the equation? 40 e to the minus 0.06, and what did they have? Was it a D? Yeah, D. Okay, that's what I'm solving. Okay, now in order to solve this, I want this to be by itself. Okay, it is not by itself. How can I get it by itself? I can't take log now. I want it to be by itself before I take logs. It's multiplied by what? It's multiplied by 4. I want to divide by 40 to get it by itself. So if I divide everything by 40, I get 15 over 40 equal e to the minus 0.06 d. Now do I have the exponential all by itself on the right? Answer would be yes. Now I'm prepared to do what? To solve for that exponent, I have to use what? Logarithms. I'm going to take the log, what base? Log base e of both sides. So that's going to be the natural log of 15 over 40 is equal to the natural log of e to the minus 0.06 d. The reason I do this, on the right side of the equation, what is the natural log of e to the minus 0.06 d? It sounds like a lot, but what is it? Log base e of e to the minus 0.06 d. It's just this. That's how I solve for the exponent, okay? So this just means that natural log of 15 over 40 is equal to minus 0.06 d. Okay, that's the property we dealt with logarithms, that the log base e of e to the minus 0.06 d. Log base e of e to, I don't care what this is, whatever the heck this is, whatever strong, whatever you want to use. Log base e of e to anything, that's how you solve for the exponent. These are inverse functions of each other, okay? So you need to get to where you recognize something like this, natural log of e to something, that's how you solve for the exponent. Now what am I trying to solve for? I'm trying to solve for what? What variable? D. Is D by itself? No, it's multiplied by what? Negative 0.06. How can I get the D by itself? Divide by what? Yeah, negative 0.06. That will get D by itself. So that will tell me that D is equal to the natural log of 15 over 40 divided by negative 0.06. So D is the natural log of 15 over 40 divided by negative 0.06. We will go further. So I will go natural log 15 over 40 divided by negative 0.06 equal 16.35. So I get my answer is 16.35 what? Days, right? So 16.35 days until what? Right, until it gets to 15 watts. So it's going to take 16.35 days until this battery has 15 watts of power. Okay? So in all of these, you're going to need to spend time with them. They're exponential models. If I give you the time unit, that's the exponent, you're solving for future value. If you have to solve for the time, you're solving for an exponent. You solve for the exponent by taking what? Yeah, the log of both sides of an equation. Okay? Now let's look at one more and then we're done. A construction crew is building an apartment complex. The progress is exponential and it follows this model. F is the number of finished apartments. It is equal to the number of total apartments times 1 minus e to the minus 0.01 w, where w is what? The number of weeks, okay? If I have 100 units, how many will be finished after 21 days, okay? So in this, 100 represents what variable? It's A. I've got 100 apartment units. What am I solving for? No. I'm solving for F. How many will I have? Okay, that's what I don't know. They tell me 21 days, but my model has time measured in what? Weeks. So how many weeks is this? 3 weeks, okay? So I need to plug in all of this into this equation. So I get F is equal to 100, 1 minus E to the minus 0.01 times 3, okay? The nice thing about it, you don't have to do this and then figure out this and then subtract 1, and your calculator will let you put all of that in into one big equation, okay, or one big expression. So it's 100, 1 minus E to the negative 0.1 times 3. So 100 times, parentheses, 1 minus E raised to the negative 0.1 times 3, right? And that is 25.92. So what does that represent? That's the number of what? Finished apartments, okay? Now, what does it mean to have 25.92 apartments finished? Right, and I would take this problem either way. It means, technically, to the letter of the law, how many have you finished? You've only finished 25, but you're close to finishing 26. So I would take, in this case, it's approximately, it's about 25 or 26 finished apartments, okay? Either one of those. I mean, like I said, the harder work is getting to that number. Once you get there, if I can look and see your logic, oh yeah, it's about 25 or 26 that are finished. Or if you just wrote 25, you'd be right, or if you wrote 26 on this one. What if it was 25.1 apartments? Yeah, I would say I wouldn't take 26 as an answer on that one. So I would say, okay, yeah, that's 25 complete. Okay. So anyway, that one you can see where the logic makes sense. You can interpret either ways. Now the next one, when I look at this, I'm going to look at the first two words. How long? What do you think they're asking me to solve for? What variable? Time. Okay, time is my what? It's my exponent. I will need to solve this with what? Logarithms. I know all of that just by reading these first two words. How long will it take? That tells me they're solving for time. How long will it take to finish 20 apartments in a complex of 150? Okay? I need you to stay with me. This is probably as complicated as it gets. I need to plug this into the original equation. So what is the finished number of apartments, which is what? 20 equals what? What is the 150? That represents what in this equation? The A, so 150. And then I had what? 1 minus E to the what? Minus 0.1 times what? W for the weeks, okay? And I'm solving this for what? W. So what I want to be by itself is that, okay? Is it by itself? No. I got to get it by itself. What's the first thing I'm going to do? I'm going to divide by what? 150 on both sides. Now when I do that, I get 20 over 150 equal 1 minus E minus 0.1 W, okay? Now again, I want this to be by itself. It is not by itself. What can I do now to get it closer on its way by itself? Subtract 1 from both sides of this equation. So I get 20 over 50, 20 over 150 minus 1 equal minus E to the minus 0.1 W. Okay. I want this to be by itself. Is it by itself? What's it got now that's in the way? That negative sign. So what could I do to this? I could divide by -1 or multiply both sides by -1. Okay. On the left side, I will get 1 minus 20 over 150. Everything just changes signs. What do I get on the right? So I get negative 20 over 150 plus 1, and on the right side I get e to the minus 0.1w. Now, do I have this all by itself now? Pardon me? Well, when you multiply the negative, it doesn't multiply by the exponent. It multiplies by this. Okay. Now, what do I do to both sides of this? No. I'm solving for the exponent. How do we solve for the exponent? We have to take the natural log of both sides. So, natural log of 1 minus 20 over 150 equal the natural log of e to the minus 0.1w. Please tell me you know the natural log of e to the minus 0.1w is what? You got to recognize this. This is the reason I did all this is so I can solve for the exponent. That's minus 0.1w equal the natural log 1 minus 20 over 150. I'm trying to solve for what? W. Is W by itself? No, it's multiplied by what? Negative 0.1. What can I do to get the W by itself? Divide by negative 0.1. So now this is going to be my final solution is W equals the natural log 1 minus 20 over 150 over negative 0.1. Off the top of your head, does anyone know what that is? This is me being facetious. Okay. Danny? So the natural log of 1 minus 20 over 150, all right, divided by negative 0.1 equal 1.43. So let's go back. What does that mean in the context of my problem? What does that mean? W represents what? Time, weeks. So it means in 1.43 weeks to do what? Yeah, to finish 20 apartments. Okay. Now guys, this is as hard as it gets. There are a lot of steps, but these are algebraic steps, okay? You did have to take the log of both sides, but isolating that W, dividing by a number, adding a number, all that, those are algebraic steps. You need to be comfortable with that, okay? So now, before we go, if we go back to our original model, everything is going to look like this. Y equal a to the bx. Y is always my future value. This number a, whatever it is, that is always my initial value. B is telling you whether or not this is growing or decaying. X always represents time in this case, okay? If I give you time, how do you find the future value? If I give you the variable for time, how do you find the future value? No. If I give you the time number, how do you find the future value? You just plug it in your calculator. If I ask you to solve for time, you're going to have to use what? You have to use logarithms, okay? So you've got to be comfortable. That's the one thing that carries over from the last unit. It was on your quiz on the TI Inspire page from the last time we had a quiz, okay?